from other institution as well as research scholars as well as the students here. So on behalf of Triple IT and our fraternity, I Dr. C. Vishal Tripathi as the FDP coordinator as well as the faculty in EC department, I welcome you all. Welcome you all in the online FDP on system engineering on topic recent trends and advances in IoT, sponsored by AICT Training and Learning at Al Academy here. So in this session, our speaker is Dr. Muneedra Ojha. He is going to discuss about the IoT with Python here. So before we start here, let me give some brief bio about Dr. Ojha here. Then I will request him to continue. So before that, so Dr. Muneedra Ojha is an assistant professor, and Dr. Syamapsad Mukherjee, Triple IT Naya Raipur here. So he has a versatile experience in a lot of universities here. So he is in Triple IT Naya Raipur here from January 2017 to till date as assistant professor in Department of CSC. During the August 2016 to January 2017, he was associated with Munjal University's BML Munjal University in the CSC department as assistant professor. During July 2014 to May 2016, he was working as a guest faculty as Department of Information Technology in Triple IT Allahabad. And during the January 12 to the July 2014, he was associated as assistant professor in Department of CSC, Srinagar University. During August 9 to the October 11, he was a lecturer in Department of Information Technology, Triple IT Allahabad. During the March 2009 to July 2009, for the short span, he was a lecturer in CSC Department, JP Institute of Information Technology. During the August 2006 to December 2008, he was a graduate research assistant, University of Missouri, Columbia, Missouri, USA. August 4th to the July 2006, he was working as assistant system engineer, Tastar Consultancy Services, Noida here. He has completed his PhD from Triple IT Allahabad. He has completed MS from research here from University of Missouri, Columbia, USA. His present research interests include multi-objective optimization, evolutionary algorithms, machine learning, artificial intelligence, and multi-agent system here. He has nominated with such awards here, so few accolades regarding his professional careers are represented Indian delegates at International Youth Forum, Inter RRA 2010, Novosibirsk, Siberia, Russia, funded by DST, Government of India. He earned graduate research assistance during MS at University of Missouri, USA. He earned travel grant from University of Missouri for IEEE International Conference on Bioinformatics and Biomedicine, Philadelphia, USA, in November 2008. Till present, he has published more than 7 research papers or journal papers here in the different reputed journals. He has published 14 conference papers in the international and national conferences here. And moreover, he is a very active member of IEEE and ACM Society here. So with this, I now request Dr. Muneedra Ojha to please take over this session. Sir, please.
Hello, am I audible, sir?
Yes, you are perfectly audible, sir. Please
Okay,
say.
so thanks a lot, Dr. Tripathi, for sharing my biodata and introducing me. As Dr. Tripathi told me, I am employed as assistant professor in Department of Computer Science at DSPM IIIT Naya Raipur since 2017. And during this period, I have been taking courses on artificial intelligence, machine learning. Moreover, I deal with programming in Python, and my whole objective is towards identifying events in video data through deep learning and other machine learning techniques. So nowadays I have been working on deep learning techniques and semantic web and amalgamation of semantic web and deep learning techniques. Today my topic of presentation in this lecture would be IoT with Python. Okay. So for that I would take a request from Dr. Tripathi to share my screen.
Sir, you can share. Yes.
Yeah,
Sir.
thank you. Right. So for this lecture, I have decided instead of giving this presentation on a PowerPoint presentation, I would be more than happy to take it on Google Colab. This way, I will also be introducing you to the Google Colab platform at which we can do Python programming. I don't know. I understand this is an electronics workshop, and most of you are electronics experts, okay, employed or associated with Department of Electronics and Communication. So I took it upon that I will also introduce you to a new platform that we have been using for Python programming nowadays, for machine learning, deep learning, and Python programming. And this is a very good platform provided by Google, which is a co-laboratory kind of thing, and abbreviated as Colab. So you can go to Colab using colab.research.google.com, and all the facilities that are there will be provided to you free of cost. And you can see over here, I have this um, connecting button which will connect me to the Google server so that I can run my programs, all the Python programs on Google server. So Google will provide me a space for storing my programs, running my program, for storing my data, as well as it will give me a RAM space. So as you can see, if I zoom it a bit, you can see that I have been provided with 0.76 GB of RAM. I'm using 0.76 GB of RAM out of 12.72 GB, and I'm using 30 GB of disk space out of 107 GB that is provided to me by Google. So this comes free of cost with your um, Google account. You can use it to create beautiful programs, beautiful presentations, and you can do it for experimentation. You can use it for experimentation. So most of our Python programming, I take my lecture on Google Colab only, so that I'm able to display the text content of the lecture, as well as I can discuss the code immediately over here. As you know, the topic of today's lecture is Introduction to Python in IoT, or Python with IoT, or IoT with Python. So I'll be talking about one of the projects that we can do on Raspberry Pi, and I'll be doing some Python programming so that you have a fair idea of how we deal with Raspberry Pi platform through Python. Okay, and I'll be taking up a simple capstone project at the end, which will be building a motion activated alarm system. And with this, I will actually help you understand how do we deal with a Raspberry Pi through Python. Okay, so I hope my screen is visible to all of you, and if it is, let me just do it a full screen. If it is not visible, or you want me to zoom it, unzoom it, just let me know. Okay, so I think I understand many of you will be on mobile platforms also, so some of the time I feel that people have problem seeing what is written over here. Okay, so I understand you had a lecture on Arduino platform, and I don't know whether you had a Raspberry Pi introduction in this workshop or not, or how much you know about Raspberry Pi. But let me just give you a brief intro of Raspberry Pi, and then we will move on to our programming part. So Raspberry Pi is a single board computer developed by Raspberry Pi Foundation, and that is a UK based charity organization. And this lecture is taken from the source that is provided over here. I'll share my lecture with you, so you will have a fair idea of what we are doing and how you can run this code also. So at the end of this workshop, probably Dr. Tripathi will be sharing my code with you, and you will have access to all the content that is written over here. So originally designed to provide young people with an affordable computing option, that was to learn how to program. Okay, it was developed as as an affordable programming, affordable computing option in place of PCs that are more prevalent today. It is a massive following. It has a massive following in the maker and do-it-yourself communities because of its compact size, full Linux environment operating system, and general purpose input output pins. So the Raspberry Pi is a mini computer. Okay. So instead of calling Raspberry Pi as a board, microcontroller board, it is better to call it a single board computer. With all the features and capabilities that are packed into this small board, there's no shortage of projects and use cases for the Raspberry Pi. If you see Raspberry Pi, probably whatever a computer can do up to a certain extent, you can do all those activities through Raspberry Pi as well. So if you see projects like line following robots, home weather automation, home weather station, retro gaming machine, or home automation is a project that my students under my guidance have done. This home automation in which through an app they can automate all the electrical appliances at home. Retro gaming machines, real-time object detection camera, Minecraft server, button control music boxes, media center, and remote experiments on International Space Station as well to the very extreme. Okay, so you see all of these are famous with one or other application domains like robotics, weather station, home automation, gaming machines, object detection. So surveillance can also be done through this. Edge computing can be implemented through these Raspberry Pi boards. Minecraft is a very famous gaming platform at which even kids are being taught how to play Minecraft, and this is a very famous game currently owned by Microsoft. So Minecraft server is also provided over there. Then you have music uh, aficionados can have button controlled music boxes over here. You can have media center, and to the very extreme, you can do experiments on ISS through these Raspberry Pi boards. So basically, if you can think of a project that would benefit from having a credit card sized computer, you can imagine a Raspberry Pi board attached to it. Okay. So Raspberry Pi is a fantastic way to bring your Python projects ideas to life. If I could give the Raspberry Pi board overview, Raspberry Pi comes in variety of form factors for different use cases. Okay. So what we have over here is the most recent version of Raspberry Pi 4. So instead of calling Raspberry Pi, people also abbreviate it as RPi, and RPi is the shorter version. People call it RPi. In this, we have, you can see, and just imagine it to be a miniaturized version of the motherboard that you would have seen in the computer. So you have a micro SD card slot over here. As you can see, this is external display port in which you could connect a monitor, and that monitor will be connected over here. You have these HDMI ports with which you can connect your monitor or other HDMI connection devices. You have a USB port over here with which you can connect USB devices. A camera module is provided over here. Audio video jack is also provided. Then in the RPi 4 module, you have USB 3.0 and 2.0, both ports are provided. Okay. So, and this is the Ethernet port which is provided, and power to this board is provided through USB power port. So USB port is given with which you could provide the power. You could power this board. So eventually, this is a kind of a small computer in which you have all the functionalities and whatever accessories you have associated with the computer, you can attach all of it to the RPi board. RPi board contains the following components like general purpose input output pins, GPIO pins that we famously call. These pins are used to connect the RPi to electronic components. We have Ethernet ports, and this port connects the RPi to a wired network. Two USB 3.0 and two USB 2.0 ports are also given. We have AV jack, camera module port, HDMI ports, USB power port is provided. Then you have external display port which could be used to connect the official 7-inch Raspberry Pi touch display for touch based input on the Raspberry Pi. So you can have touch based input, the official 7-inch RPi touch display with the um, board. Then you have micro SD card slot underside of the board. Okay, that is also provided. If you have to compare between RPi and Arduino, Arduino is just a platform which provides a hardware and software interface for programming microcontrollers. Okay, Microcontroller, which is an integrated circuit, allows you to read input from and send output to the electronic component. However, Arduino boards generally have very limited memory, so they are often used to repeatedly run a single program that interacts with the electronic devices. However, on the other hand, Raspberry Pi is a general purpose Linux based computer. You can assume it to be a miniaturized computer. So all the time I'm talking about the miniaturized computer because it has an operating system. It has a full operating system with GUI interface that is capable of running many different programs at the same time. Okay, although it is so miniaturized that you might have to do some extra work to set up operating system on the board, and all the operating system is stored in the micro SD card. But still, with a few initial setup issues, after resolving few initial setup issues, you can have a full-blown computer with this RPi board. The RPi comes with a variety of softwares that are pre-installed, including a web browser, an office suite, a terminal, and even the Minecraft. RPi also has a built-in Wi-Fi and Bluetooth to connect to internet and external peripherals. For running Python, the RPi is often the better choice as you get a full-fledged Python installation out of the box without any configuration. Okay, so you can have Python server that is already installed and you can configure it to run your Python programs. So I have skipped the part in which I deal with how you are going to connect RPi board, how you do the operating system installation on the RPi board, and how do you make it ready to run. Probably that part should be left out to the for the BTech students. You guys are experts, so you can sort out how to manage that, and you are expert in doing that. So in this part, in this lecture, I'm actually skipping some of the hardware part, some of the parts with which you manage the hardware, because I know you guys are expert of that. I'll be dealing more towards the Python and how to do Python programming on RPi board. Okay, so to do the Python environment setup, we have a RPi Foundation actually specifically selected the Python as its main programming language because of its power, versatility, and ease of use. Python comes pre-installed on Raspbian, so the operating system that comes with the RPi board is called Raspbian. Okay, on the basis of Debian flavor of Linux operating system, because Raspbian is actually a derived version of Debian operating system, so that is why the name is similar. It is called Raspbian. So Raspbian is the operating system, Linux operating system that is installed on RPi, and Python comes pre-installed with Raspbian. So you'll be ready to start from the word go. There are two popular choices for running Python code on Raspberry Pi. That is through Mu editor. There is a Mu editor which is provided with the pre-setup, and you have an option of editing the Python program or creating Python programs remotely through secure shell connection. Okay, so let's start. We will have a discussion of both of them gradually, and let me just introduce you to the Python Mu editor of the Python, and then we will discuss how we can do the same thing using SSH connections. The Raspbian operating system, which comes pre-installed with the RPi board, comes with several pre-installed Python IDEs. IDE stand for Integrated Development Environment, that you can use to write your programs. One of these IDEs is Mu. It can be found in the main menu by, if you go to RPi icon and you click on programming, then you can go to Mu. When you open Mu for the first time, you will be given the option to select Python mode for the editor. So for this tutorial, we are going to use Python 3. There are different flavors of Python, that is many people at this time as well use Python 2. However, starting 2016, Python 3 version has come up, and even the Python community, the original Python support group is also supporting Python 3, only they are gradually removing the support for Python 2. So I will not be talking about Python 2. However, there are a lot of programs which exist, and probably if you go look for code for Python programs or IoT programs in Python, you will find many programs written Python 2.6, 2.7. But we will not talk about that. There are a few differences between Python 2 and Python 3, and they are very trivial. So as soon as you know, you will have no problem shifting from Python 2 to Python 3. So at this point of time in my lecture, I will be talking about Python 3 only. This is the interface that I talked about. When you click on the RPy icon, you can go to programming, and from there you can select the editor Mu. So when you select the editor, you will have a choice of running it using the mode. So in this mode, you select the Python 3. Okay, click OK. There's a chance that Mu may not be pre-installed on your version of Raspbian. In such a cases, what we can do, we can install it by going to the location where again by RPy icon, click on preferences and then recommended software. Now this will open a dialog containing recommended software for your RPy. Check the box next to Mu and click OK to install it. So you see over here, these are the recommended softwares that are recommended. If our Mu is not installed, you can always install it through the um, RPy icon, preferences, and recommended software. So in the list of recommended software, you can see Mathematica is also there, Minecraft is also there, Node-RED, Orca, all these are there. So if you look at the list of categories that is provided in it, you have a list of software which are related to education, games, internet, office, programming, and universal access. So a number of software suites are provided to you, either pre-installed or free to install. Okay, and you can choose if it is not installed. While Mu provides a great editor to get started with Python on RPy, you may also want something more robust, and then in that case you may want to edit remotely over SSH. Often there are cases you won't want to spend the time hooking up a monitor, keyboard, and mouse to write Python or RPy program. So RPy allows you to connect to a Raspberry Pi board remotely over SSH. Now to enable SSH, you have to, so before you can connect your RPy board over SSH, you will need to enable the SSH access inside RPy preference area. So the same way you found out the Mu, if it is not installed, you go to RPy icon, then preferences, and then you check the Raspberry Pi configuration. Once the configuration appears, you select the interfaces tab and then enable the SSH option. So this way, you see over here, I have this in the interfaces tab, you have SSH and you enable it and then press OK so that SSH connectivity is enabled. Once you have SSH connection established, SSH action connection access allowed, you need to find the IP address for the RPi board so you can connect to it from any other computer. How to determine RPi IP address? You need to access the IP of this RPi board using the accessories and terminal option. So you can go to the RPi icon, click on accessories, and then choose the option terminal. Once terminal is open, you enter the following command, which is hostname -i. This will display the current IP address for your RPi module. So with this IP address, you can now connect to your RPi remotely, and it will give you the IP address of your. But first, you need to be connected to an internet, to a connection through internet, so that you are actually having an IP address. So these parts I have skipped, and I assume that these things are already pre-set up. So you got the SSH access, you got the IP address, and now we can connect to RPi through SSH. Through if you have to connect to SSH, that this is the well-known command. You type SSH script and then you specify pi @ and then you specify the IP address. Okay, so pi@IP address will connect your RPi board to the computer with which you are trying to connect. You will be prompted to enter the password you created when running the setup wizard during the RASPBN installation. If you didn't set a password, then the default password would be raspberry. Okay, so these are the default things. You should know these things. Now you can enter the password, and after it connects, you will see rpi command prompt, which is pi@of raspberry pi. Okay, then you have colon tilde and a dollar prompt will be presented unto you. Now this way you have connected, and now you are ready to start programming Python. Okay. You can immediately start the Python interpreter. You can type Python 3, type in some Python to run it on RPi. Like you can type a print command, print hello from your Raspberry Pi, and then you will get this message, hello from your Raspberry Pi. And if this print command runs successfully, it means that your RPi connection is established, your RPi board is running properly, and the Python server is also running properly. The interpreter is running properly, everything is set up properly. Now from here we start the Python programming on RPi board. So before that we need to make some environment, we need to create some environment for our programming. We need to create a Python project folder in which all the programs that we'll be creating after it will be kept, and we'll be talking about that folder only. Okay. So before you start building projects with Python on RPi, it's a good idea to set up a dedicated directory for the code. RPi has a full file system. As you understand, these are the differences which make Arduino and RPi extremely different. RPi has a complete operating system. So whatever functionality an operating system gives you, like network connectivity, disk partition, storage space, file and directory structure, all these things, login, access, all these things are provided on RPi board. So RPi has a full file system, and with many different directories. Let's create a directory called Python projects, where we will be storing our Python code for the projects that we are going to do below. Now using new editor, we can create directory just like we create in our computer. You go to RPi icon, then programming and new, it will open new. In the menu, you click on new in the menu bar to create an empty file. Okay. Click save in the menu bar and then navigate to the home Pi directory, the directory drop down. Now you can click on the create new folder icon in the top right corner. You can name this directory whatever you want, but for the purpose of this tutorial, I'll be naming it Python projects. Then you can click enter or save, and then you close the uh, interface so that you have your new folder, that's Python projects, created in the home Pi directory. Okay. So when I say that you go to this folder, click on this menu and open this menu, I am assuming that your RPi board is already connected to a keyboard, a mouse, and a terminal. Okay. If you have to do the same thing using SSH, you will use the command line to create Python project directory. And since you will be accessing the RPi command line, you'll need to use a command line text editor to edit your project files. So for that purpose, Nano and Vim, which are the basic editors provided in Linux operating system. So Nano and Vim are both available in Raspbian and can be used to edit the project file. You can also use VS Code, Visual Studio Code, to remotely edit files on RPi, but for that, some extra setup is required that is beyond the discussion of this lecture. If you haven't currently logged into RPi, then you need to use the IP address of the RPi board and to SSH into the RPi from your computer. And for that, as I've already discussed, you need to run this command on the computer. from which you are trying to connect the RPi board. So SSH pi and then IP address. Once logged in, and it will ask you to enter the password. Once you have logged in, it will give you the command prompt, RPi command prompt. By default, when you SSH into the RPi, you will start in the home pi directory. Okay, you can confirm it using the uh, pwd command as well, and that is the common Linux command with which we know the present working directory. Okay, so present working directory, as soon as you log in, your directory will be the pi directory. And if you run the command pwd, which stands for present working directory, it will be shown to you as home/pi. If for some reason you are not in home pi directory, then switch to it using the cd command, which is cd space home pi, and then uh, yeah, you over here as it says cd home pi, and you will be moved to home pi. Okay, so in the Mu IDE, we had this option of graphical user interface, in which we created using new on menu bar. Over here, you do not have a graphical user interface, so you will need to run this command make dir, which will create a directory, new directory for you, and we will call this directory Python projects, the same as the one with which we created a directory in Mu. With the Python project directory created, use cd Python projects to go into the directory. I think I should have written this in the command. Okay. So this will be like this. Yes. So use cd Python project to get into the directory. Now this is the command cd Python projects, and cd Python project will take you to Python projects directory. If you do pwd at this point of time, it will give you /home/pi/Python projects. Now at this point we are ready to start coding. Okay, and then the first thing that we'll do is we learn how to interact with physical components. In this section, we learn how to interact with different physical components using Python on the RPi board. We will be using GPIO0 library that comes pre-installed on Raspbian. It provides an easy to use interface to interact with a variety of GPIO devices connected to the RPi board. So these are some of the electronic components which we will be using in our further discussion. A breadboard, I don't need to explain all of these in detail because I know you guys know more than me, but still just a quick um, understanding, more for me than for you, so that we can be on the same page. A breadboard is an essential tool when building circuits. It allows you to quickly prototype your circuits without having to solder components together. So this is the figure of a breadboard. It is more or less necessary for our BTech student, but for you it is a um, very easy thing. Okay. Now you will need jumper wires. Jumper wires allow you to prototype the connection of your circuit without having to solder parts between GPIO pins and components. Now they come in three different types. We all know male to male, female to male, and female to female. It would be good to have at least 10 to 20 of each type when you are building your RPi projects in Python. Okay. Among other components, we will need light emitting diodes, LEDs for our project. We will need a tactile button. We will need a 330 ohm resistor, an active piezo buzzer, and a passive infrared motion sensor. So these are the components which we will be needing for the project that I'm going to discuss in today's lecture. GPIO pins, the Raspberry Pi features 40 GPIO pins along with top edge of the board along the top edge of the board. You can use these GPIO pins to connect to RPi, connect the RPi to external components. Okay, so this is the layout of the general purpose IO pins, and there are 40 pins which are arranged in this order, and if you need, you can look at this layout. Now, the RPI features 5 different types of pins. First, GPIO pins. These are general purpose pins that can be used for input or output. Then you have 3v3. These pins supply 3.3 volt power source for components. 3.3 volt is also the internal voltage that all GPIO pins supply. Okay. You have 5V. These pins supply a 5 volt power source, the same as the USB power input that powers the RPI. Some components, such as passive infrared motion sensor, require 5 volt of power. Then you have GND pins, which stand for ground connection for circuit. Then ADV, these special purpose pins are advanced and was not covered and not required in this tutorial. First one that we are going to discuss over here is the tactile button. Okay, so we will see some of the components, and then once we are done with these components, we will do our capstone project in which we will create the motion sensor alarm. Okay, which will be our last part of this lecture. First, we need to set up. So our first circuit, we are going to connect a tactile button to the Raspberry Pi. Tactile button is an electronic switch that, when pressed, closes a circuit. Okay, so you all know this. When a circuit is closed, the RPi will register an on signal, and you can use this on signal to trigger whatever action you want to perform. In this project, we will use a tactile button to run different Python functions based on the state of the button. Now let's start wiring this button. First, we need to connect a female to male jumper wire from Raspberry Pi ground pin to the negative rail of the breadboard. So for this purpose, let me just unzoom it a bit. I hope it is visible to all of you, whatever is written. Okay. So we will connect a female to male jumper wire from RPi ground pin to the negative rail of the breadboard. So this is what has been done over here. Okay. Then place a tactile button across the gutter in the middle of the breadboard. That is what is done over here. Connect a male to male jumper wire from negative rail of the breadboard to the row where the button's bottom left leg is placed. Okay, so this is what is happening over here. Connect the female to male jumper wire from RPi's GPIO 4 pins to the breadboard row where the button's bottom right leg, okay, bottom right leg, so this is the one which is over here, is placed. Okay, so this is like this, and then male to male jumper is connected over here, bottom left and bottom right. So these two are the ones which we are talking about in 3 and 4. Now once we have completed all the wiring, we can move on to our programming part. In this, you see, so inside the Python project directory that we created earlier, we create a new file which we call as button.py. Okay, so this will be the Python program that we will need for our Python programming, and we will write all the codes in button.py. When we create a Python program, all the code is written in files which have an extension of .py. Python programs are interpreted programs. Unlike many programming languages which are compiled, Python programs are interpreted, which literally means that every line of code is executed independently of the remaining part of the code. So, in the difference between compiled and interpreted is that when we have a compiled program like C programs, you might have a C program in everybody's first semester, BTech first semester, probably everyone studies C. So you know C program is a compiled program in which C compiler does a two pass on the whole program. So it reads the first first whole program, then tries to understand the syntax of whole program, whether syntax is correct or not. Then it reads the program again, which is called the second pass, at which it tries to understand the meaning of the program. So whole syntax and semantics of the program is understood by the compiler. So those programs which are read in bunch, the whole program is read, is and then it is sent for, if it is correct, sent for execution, are called compiled programs. However, Python is an interpreted. So if it is interpreted program, the difference between compiled and interpreted is that, in contrast to compiled program, the interpreted programs are executed one line at a time. Just like an interpreter, suppose two dignitaries are sitting and both of them do not know the language of each other. Like let's assume uh, Vladimir Putin and Donald Trump are sitting and in a summit, and they do not know the language of each other. So there will be an interpreter which will be listening to one statement by Donald Trump and then translating that to Russian and then speaking it to Vladimir Putin, and vice versa, is listening one sentence of Putin and then translating it to English and then speaking it to Donald Trump. So this way, the interpreter, the translator, is actually listening one sentence at a time and then executing, translating. Same thing goes over here with the interpreter. It reads one line at a time, understands it, translates it to the machine language and executes it. Then it moves on to the next statement. So this is why this is called an Python is called an interpreted language. Now, so we have over here created a Python file button.py. Whatever we do, we will write all the code in button.py program. Okay. If you're using mu, then create the file with the following steps. Okay. We can go to new menu, click save, and then go to Python project directory, save the file as button.py. So whatever new file you have created, you click on save. When it asks where to save, you go to this directory and then save it in the button.py folder. With the file created, now you are ready to start coding. Okay. In Python, just like C, we have several header files which we use before we start programming. In Python as well, we have to import some of the pre-built files. We normally call them modules in Python, but you can treat them or you can understand them to be just like the header files we are used to in C. So from GPIO 0 module, this is the package that comes pre-installed with Raspbian. We import button module, and then from signal module we import pause. So these are the two classes that we'll import. Create an instance of the button class and pass the pin number as a parameter. This is the step that we will be doing again and again. Okay, and which is written over here. So when we say we create an instance of the class, it is actually some of the object-oriented programming concepts that go over here in explaining the meaning of this statement, in which it says that what we are doing over here, we have a class. Okay, a class button class is defined in the GPIO 0 package, and for this class we are trying to create an instance. We are trying to create an object of the class button. When we create an instance, we are actually trying to create an object. So at this point of time, my object is called button with small b, and button with capital B is the name of the class. Now when you create this instance, you need to specify how you need to specify the pin number, okay, which you will be using to access the button. So in you are using GPIO 4 pin, so you will pass in 4 as the parameter. So whenever this class is created, there is a constructor. That constructor will take the pin number That constructor will take the pin number and create an instance called button for you, which will now work on pin number GPIO pin number 4. Next, we define functions that will be called for different button events that are available on the button instance. So these functions are already defined in the button class. However, you need to specify what will be the actions undertaken by these functions. So these are the standard functions like button pressed. What happens when the button is pressed? So you specify, for our purpose, we just specify a print command. But then in your purpose, when you are actually utilizing this button to achieve some task, you can specify whatever code you want to write over here. So for the our purpose, for the purpose of tutorial, I just write print button was pressed, so that I know that the button is actually pressed. Then the button held function works when you press and hold button for some time. So is if this function runs, it will print button was held, and finally when button is released, this function will be called and it will be printed as button was released. The button class has three event properties, that those are when pressed, okay, when held, and when released. And these properties can be used to hook up different event functions. So with these three properties, you can do whatever you want on the basis of whether button is pressed, whether button is released, or whether button is kept pressed or held. Now, as I told you, when pressed and when released properties are self-explanatory. When held property lets you keep pressing the button for some time. So this property will be called only if the button is pressed and held pressed for a certain amount of time. The hold time of when held property is determined by the hold time property of the button instance. So as soon as you create this button instance, there are few of the properties associated predefined which are activated along with this instance. And these properties are when pressed, when held, when released. When pressed, when released are self-explanatory. When held is activated when you press the button and keep it pressed for some time. Now, how much time? That time can be defined by the hold time property of the button. The default hold time property is 1 second. However, you can change it just like this. When you create the button instance, you can pass on this parameter like 4, indicating the GPIO pin 4 is used. However, hold time equal to 2.5 specifies that you are holding it for 2.5 seconds. Only then the held pressed when held property will be activated. Okay. So button dot when held is equal to button held, and button held function will be called over here, right? This will create a button instance that will wait 2.5 seconds after the button is pressed and held before calling the button held function, right? Now we know about different event properties on button. Let us set each of these to their respective functions that we defined earlier. So we have button dot when pressed is equal to button pressed function, button dot when held equal to button held function, button dot when released equal to button released function. Now the last thing you need to do is call a pause function at the end of the Python file. Pause function is required to keep the program listening in different event. If this is not present, the function would run and exit immediately after executing it once only. Okay, so that is why pause button is required, because after execution of these commands, your program will keep on waiting for the newer events. So the final program might look like this. You have from GPIO 0 import buttons, signal import pause, button initialize at button 4. Then you have these three functions which are defining what happens when button is pressed, when button is held, or button is released. Then you are setting the property when pressed equal to button pressed, when held equal to button held, and when released is equal to button release. Then finally you put the pause function to let the board keep on waiting. With the wiring complete and the code all set up, now you are ready to try out our first circuit. And inside the Python project directory, we run this program python 3 button.py. Okay. So here we are specifying Python 3 to start the interpreter, and then this parameter tells the interpreter which Python program is to be checked and executed. Okay. So if there is no error, Python button.python program will execute. If you are using mu, first make sure the file is saved. Okay. Then click run to start the program. You can directly click run from the graphical user interface to start the program. When the program is running, you can press the button and you should see the following in console, like button was pressed. Of course, you might have to wait for a fraction of seconds to see these results, because some of the time sensitivity of the circuit is also important. As soon as you press the button, should be displayed. However, be patient. In practice, we have seen that it lags a bit. Press and hold the button for at least 1 second and you should see the following output. Since we have in this program not specified the hold time to be 2.5, so the default will be 1 second. So after 1 second, it will display button was held. Finally, when you release the button, you should see button was released. Now we have wired and we have coded our circuit for the button. Okay. Since you used pause in your code, you will need to manually stop the program, because pause function will keep on pausing after every run. It will keep on pausing the function. It will not let it complete. So to complete it or stop it, we need to press Control C. Okay, or from mu you need to click on stop to quit the program. Now, with the first circuit with you under the belt, you are now ready to start controlling other components. Now, let us look at LED devices. So, for this circuit, we will use Python to blink an LED on and off every second. Now, LEDs have two legs. The longer leg is the positive or anode, and the shorter leg is negative leg or cathode. The electrical current enters the LED through its leg, the longer leg, and exits through the shorter leg. Current can only flow in one direction through an LED. So make sure we are connecting jumper wires to proper leg of the LED. Now we do this wiring. We connect a female to male jumper wire from RPI to ground pin to the negative rail of the breadboard. We place LED into two holes on the breadboard that are next to each other but not in the same row. Okay, so we do it like this. The longer and the shorter are placed but not in the same row. This is the row. Place the longer positive leg of LED into the hole on the right side and place shorter negative leg of LED into the hole on the left side. Place one end of a 330 ohm resistor into a hole in the same breadboard row as the negative leg of the LED. So you see this is put in the same row of the negative leg. Place the other end of resistor into the negative rail. So again the other end is also placed in the negative end. Now we connect female to male jumper wire from RPI to GPIO 4 pin to a hole in the same breadboard as the positive leg of LED, like this one over here, right? This yellow line. Right. So this is the complete setup. So you can see with this diagram, you can see what we have achieved over here. We have put the longer leg into this row, shorter leg into this row. With the shorter leg, we attach a resistor. With the longer leg, we attach our, sorry, we attach our female to male jumper wire. Okay. Now to program the LED, what we want it that as if we give the signal, it should blink, and then if we give signal, it should stop. So we start again by creating the circuit inside the Python project directory, and we call it led.py. Okay. So using SSH, I create a file called led.py using the touch. Touch will give me an led.py file opened, and then we will create an instance of LED class and call it blink method to make the LED blink. Okay, so there we will create an LED class, and it will have a blink method which will be invoked so that our LEDs can blink on and off. The blink method has a default timeout of 1 second. We can change it. However, it has a default time, and that is 1 second. LED will continue to blink on and off every second until the program is exited. So we start by importing LED from GPIO0 module and process from the single module. From GPIO0 we import LED, and then from signal we import pause. Just like we have to create an instance, and we are going to put it into GPIO pin 4. So we will, while creating the instance, just like we did above with the button, we will pass on parameter 4 indicating what pin number are we going to put our LED into. Now we can call the blink method on LED. So led.blink function will be called, and then finally we add the pause function to let it pause and listen to our commands. The final program looks like this: GPIO 0 import LED, GPIO signal imports pause, LED is equal to LED 4, indicating number of this GPIO pin at which you are going to present the code. Then LED.blink, and then pause, indicating that this function is called, and it will make the program wait for other functions. You can save the file and run it to see whether LED blinks or not. So on the SSH, you have this Python project, python 3.led.py. As soon as you run this project, the LEDs should start to oscillate among its colors. Okay, it starts to blink. But if you do this, you will need to stop it using Control C or stop in mu. So you will need to use Control C or the stop command option in mu. So this way we have seen how to control an LED, and it was very easy. Now let us move on to buzzer. So we are going to create a buzzer so that as soon as we ask it to, it creates a sound, it produces buzzer. Now here we will be using the piezo buzzer that I had discussed earlier. We will be wiring an active piezo buzzer to RPI. Piezo buzzer emits a tone when a current is applied to it. Using this component, our RPI will be able to generate sound, and this is what we want because I want a motion sensor which will be an alarm also. Like LEDs, a buzzer has a positive and negative lamp. The positive leg of the buzzer will either be longer than the negative leg, or there will be a positive sign on the top of the buzzer. So this way you could identify the buzzer, which buzzer is positive, which length of buzzer is positive, which length of buzzer is negative. We place a buzzer on the breadboard, noting the placement of buzzers positively. Okay. Now, as it suggests, we connect a female to male jumper wire from RPI's ground pin to a hole in the same breadboard row as the negative leg of the buzzer. So this is what we are going to do, from breadboard to same negative hole, some hole in the same row of the negative leg. Connect a female to male jumper wire from RPI's GPIO 4 pin to a hole in the same breadboard row as the positive leg. So this is what is this yellow one is the one which we are talking about now. Once you have done the wiring, you can start programming, and we do the same using the uh, command that we have seen earlier as well. We have to call the touch function. Touch function will create a buzzer.py file and open the editor for you, where you can write your command and statement, right, and your instruction for Python. Now in this code, you will create an instance of buzzer class and call its dot beep property, dot beep method, to make the buzzer beep on and off. The beep method's first two parameters are on time and off time. So on time will tell when the buzzer starts, and off time tell when the buzzer stops. These parameters take a float value to set how long the buzzer should be on and off, right? The default value for both is 1 second. When parameter stay, uh, when these parameters take a float value to get how long the buzzer should be on and off. Okay, and default value for both is 1 second. Now we can start by importing buzzer from GPIO 0 module and pause from the signal model. These are the two which we have already seen. Next, we create an instance of buzzer called buzzer. Again, what we have seen in the button command in the LED class, and over here in the buzzer class. So first we used LED button class, and for that we created a button instance with passing GPIO 4 number pin to it. Then we created LED instance from the LED class, and we passed number 4 to our function, indicating that it is going to be on GPIO 4. And now over here in buzzer class, we again pass the number 4, value 4, indicating that GPIO number pin is being 4 number pin is being used. And the same, this is the instance and this is the class. Okay. With this instance, we could call the beep method of the buzzer class. So set with the beep method, we can set the on time and off time of the parameters to 0.5. Okay, so this will make the buzzer beep every half second, although that will be very irritating. But let us just try. If you feel there is a problem, then you can change it. Now buzzer.beep 0.5 and 0.5 means on time and off time parameter to 0.5. Finally, we add a call to pause, indicating that the program will keep on listening, keep on remain active. And when you want to stop it, you will have to stop it using the Control C command or the stop from the menu. The whole program looks like this, very simple 6 lines code, 5 line code, and you save it in the file. The file name was buzzer.py. When you run it, you should hear the buzzer sound on and off until you stop the program with Control C or the stop option in mu. If you're using mu, there is a chance that when you stop the program, the tone will continue. Okay, and this has caused many problems to our students, that many a time they are not able to stop the buzzer, and it keeps on buzzing. So uh, it happens because of some incompatibility between the board and the mu editor, and in that case you might need to restart mu, and even if the tone doesn't discontinue, then the ultimate option is to reconnect the ground wire. Okay, reconnect or disconnect the ground wire. This way you can stop the buzzing sound, and this is actually a step of irritation for many of our students, and whenever we do these experiments, and this happens most of the time, it happens due to some of the incompatibility that exists between new editor and the board. Now we will be installing motion sensors. I think this is the last one before we move on to our final project. Yes. So before we move on to our final project, the motion sensor is the one which we will be using to sense the motion, and through that we will actually be checking whether there is a motion or not, and through these we will uh, identify, and then the whole buzzer and the alarm system is created just to help it understand the whole mechanism. Okay, so the motion sensor circuit, we have a passive infrared motion sensor, PIR motion sensor for the RPI. A passive infrared motion sensor detects any motion in its field of vision and sends a signal back to the Raspberry Pi. When we before we could use it, we should adjust the sensor sensitivity. Okay, so we need to adjust how sensitive the motion sensor is for the motion, and how long it will send out a signal after motion is detected. So these are the two parameters that we need to adjust before we can use it. We can make our adjustment using two dials on the side of the sensors, right? You will know which dial they are because they will have a cross shaped indentation in the center, just like this. So you see, these are the two dials in which the left one stands for timeout, how much time it should keep on sending the signal, and second one is the sensitivity. The image below shows these dials on the side of the motion sensor. So as the images show, the left dial sets the signal timeout and the right dial sets the sensor sensitivity. Okay. You can turn these dials using a screwdriver, a plus screwdriver or Phillips screwdriver, clockwise or counterclockwise. If you do the clockwise, it increases the timeout and sensitivity, and if you do counterclockwise, it will decrease the timeout and sensitivity of the device. You can adjust these based on your project needs, but for this tutorial, we will turn both dials counterclockwise all the way to reduce the sensitivity and timeout. Yeah, so we are going to put them at the lowest value. Now, occasionally a motion sensor and an RPI will not work together correctly. This results in occasional false positive from the sensors. Okay, so this sometimes we have to take care of, and it requires some extra work, but it can be managed. If you're using a RPI 3, then make sure to move the sensor as far away from the RPI as possible. Once you have adjusted the motion sensor, now you are ready to set up the wiring. The motion sensor's design doesn't allow it to easily connect to breadboard. That is one of the big issues. Okay. However, you will need to connect the RPI's GPIO pin directly to the pins on the motion sensor with jumper wire. So you will need to connect to these pins from GPIO. You will need to connect the RPI's GPIO pins directly to the pins on the motion sensor with jumper wires. The image below shows the placement of pins on the underside of the motion sensor. right? So this is the one, this is the underside of the motion sensor. These are the 3 pins which you need to connect. You can see there are 3 pins. One is VCC, which is for voltage, the out pin, which is for, so you see this is VCC, the leftmost is VCC, then the middle one is out, and the rightmost is the ground pin. So VCC for voltage, out for communicating with the RPi, and G and D for the ground. Using these pins, you need to take the following steps. We first need to connect female to female jumper wire from RPi's 5-volt pin to sensors VCC input. So we have this 5-volt, and we need to connect to its connect a female to female jumper wire from RPi's 5-volt pin to sensors VCC input. This VCC input, okay, this one. Now we need to connect a female to female jumper wire from RPi's GPIO pin to sensors out pin. So this is the out pin, okay, the yellow one over here. Then finally we connect a female to female jumper wire from RPi's ground pin to sensors ground pin. So this is the ground pin, okay, this is the ground pin which is connected. The wiring, as you can see, should be as per the diagram. So if we are done with the diagram, probably we can move with the wiring, we can move into the programming part. So first, step first, in the Python projects directory, we will create our PIR .py indicating infrared sensor, PIR.py indicating this file. We will call the touch function to create a new file through SSH. You will create an instance of motion sensor class. From this GPIO0, we import motion sensor class, and with the motion sensor, we pass parameter 4 indicating our pin number, GPIO pin number, and we get an instance motion sensor. So, and pass the GPIO pin 4 as parameter. We have done it 3 times earlier also, so we are very familiar with this step. You will then define 2 functions and set them to the dot when motion and dot when no motion properties of the motion sensor instance. So this motion sensor instance has 2 inbuilt properties, which are when motion and when no motion. So this, it has to detect, it will detect, do something when motion is identified, and it will do something when there is no motion which is identified, okay, and both of these you have to specify what will be the functionalities. Now we define motion. Motion will be print motion detected. So this is the task that we are going to perform if there is a detected motion. No motion function gives you the command to print motion stopped, or there is no motion which is being detected. Now this is the way we write functions. So when we have to write a function in Python, we start with the keyword def, which stands for define, and then we give the identifier, the name of the function. Over here our function name is motion and no motion. So these are the 2 functions that we are creating over here. The round brackets stand for accepting parameters, accepting parameter for the function. So the 4 value that is being passed will is also a parameter that is being passed to the function. Similarly, when you have this definition, in this definition the function motion is defined not to accept any parameter, okay. However, there are functions which will accept parameter, just like the motion sensor constructor function will accept a parameter 4 indicating what is the pin number with which it is connected. Now in Python, the biggest change from traditional programming approach to Python is lack of parenthesis in case of writing block of code. So if you are familiar with C and you remember your C programming skills, you would remember that when we had to write a block of code, we used to do it with the curly brackets, okay. we used to do it with the curly bracket. We used to do using curly bracket. However, Python does not have this curly bracket or any bracket you used for creating block of code. What Python does is indentation. Okay, so you see this code is which is written inside this function def motion is indented 4 spaces ahead of the line. So if this is the line, so if this is the line of function definition, then this is the line of code, block of code, which is being written. Again, this is the line from which the block of code written. And this space is actually, it can be 2 spaces, 4 spaces, 3 spaces, any number of spaces. However, generally we prefer 2 space or 4 space. Google programming supports or encourages 2 spaces, and Facebook programming encourages their employees and the people who program for Facebook for 4 spaces. I normally take it to be 4 spaces because I like the indentation. So this makes our program more crispier and easier to understand. So these 4 spaces are specified over. So this indentation specifies to Python that the code which is written inside of it is actually a block of code of this function definition. Okay, and then you have 2 spaces over here, and then again it starts from the very beginning, indicating that something new is being started. When this code is indented, it means this belongs to something which is written above. And you notice there is a semicolon specified over here. When we do the for loop, when we do the while loop, or whenever we have to write a block of code in Python, we specify this colon, indicating that a block of code is going to start, and that block of code is always intended few spaces ahead of its parent code, right? Just like this. Now all the lines, if I have to write, suppose, and just for the sake of writing, for the sake of showing how the block of code would be, all these codes will have to be like this to indicate that these 4 lines of code are part of the block which is body of the motion declaration, function motion declaration. However, I'm going to delete them because they are not the part of this function, right? So this is how we program. Why we don't use parentheses or brackets in Python for this kind of blocking? Because unfortunately there are limited number of parentheses, and all those brackets have been used by Python for one or other purposes, like the round bracket. Round bracket has been used by Python to specify tuples, sorry, to specify tuples. Okay. So these round brackets are specified for tuple data structure. Square bracket is specified or utilized for creating list data structure, and curly brackets are specified for using sets or dictionaries. Okay, so this way these 3 brackets have already been utilized extensively by Python. So we are not left with any bracket which will be utilized for creating the block of code. That is why we don't have block of code over here. That was a limitation, but fortunately people have been uh, more comfortable with this indentation, and this indentation actually makes this code look beautiful, because you will be familiar that students don't prefer to indent code. They just write everything in one line. But for Python, if you write every code in one line, it will not work. It will not identify the indentation block. Fine. So we have two functions, motion and no motion, and with these two functions we have these actions: print motion detected, motion stopped. Then we print a readying sensor, motion sensor dot wait for no motion, and then we print sensor ready. Okay, so with these properties set, all the program like this, what we have over here, the motion function is set to when motion property. Okay, so where is our motion function? Motion function is over here, and when we have motion sensor, the property is wait for no motion, and when there is no motion, it says sensor ready. Okay, so motion sensor, when motion property is set to motion function, so it says that motion is set to dot when motion property and is called when the sensor detects motion. So over here we have this property of the sensor when motion, and we assign it the function motion. So as soon as there is a motion, this function will be activated and this function will print motion detected. The no motion function is assigned to this property. So whenever there is no motion or the motion is stopped, it will print motion stopped. The no motion is set to the no motion when no motion property and is called when motion has stopped for a certain period. This time is determined by the timeout dial on the side of the sensor that we have calibrated earlier. Now you notice that when motion and when no motion properties are set, there is a call to wait for no motion on the motion sensor instance. This method will pause the execution of code until the motion sensor no longer detects any motion. Because you see, if motion is always there, so it has to stop and restart its process so that the motion is uh, rechecked in a fresh manner, in the fresh cycle. That is so that this is so that the sensor will ignore any initial motion that will occur as the program is starting up. Okay, so it has to start afresh so that these functionalities could be executed. Now there are a few things you need to be very clear about when using the motion sensors. Motion sensors can sometimes be too sensitive or probably not sensitive enough. If you see these inconsistencies during running the code, you make sure to check that everything is wired correctly. You may also need to adjust the sensitivity dial on your sensor, and these are the calibrations you will need to perform. If your results are delayed in the console, then try adjusting down the dot threshold property on the motion sensor instance, and the default value for which is 0.5. Then you can do that using PR equal to motion sensor 4 comma threshold 0.2. So with this instantiation, you can do it. This will decrease the amount of motion required to make the sensor active. Now, if you need more information, you can always see the GPI 0 documentation and understand the description of motion sensor class. We save all the code and then we try to run it. We try to call the interpreter and pass the file that we have created, pir.py. It will print readying sensor. When it is readying sensor, it is waiting for all the motion to stop and the sensor to not detect any motion. At that point of time, it will display sensor is ready. Then you wave your hand in front of sensor. When motion is first detected, the motion is function is called and it will display motion detected. Now you stop waving and after some time it will display motion stopped. Okay, and be patient. It after a few seconds it will display this message. So once you are done, and we can stop this function by using the control C, because again we have this pause function which will keep on waiting in the repeat loop. Okay, and then it can stop. Finally, we have our capstone in which we are going to combine everything. The wirings over here will be like this. You have all the devices which are connected, and as you know, we have been doing the wiring. So all the wirings that is given above can be clubbed, is actually instructed over here in 8 steps, and this is the same wiring that we have done earlier as I explained before. So we have all the devices connected over here. We have tactile button, we have buzzer, we have an LED, and we have a motion sensor. Okay, having everything over here, the code goes as usual. We start by creating a file. This file will be our motion detector.py. Okay, we have this file. Now, what we are going to do over here in this file, we will be writing our timestamp at which the date and time at which the motion was detected. So we import the CSV module, so we can save a timestamp when the motion was detected. The import path is from the path lib, so that we could specify the file of path of the file. So here we import CSV module, we import path from the path lib module, then we import date and time class from the date time module, and finally we have all these things which we have already imported in the previous code. From GPI0 we import LED, buzzer and motion sensor, right? And pause is already with us. So with the imports ready, you can set up the three electronic components we'll be using, create instances of LED, buzzer and motion sensor classes. We have already seen this, but at this point of time their GPIO pin numbers will change. So let us put LED on pin number 14, buzzer on pin number 15 and motion sensor on our favorite pin number 4. We define a CSV file that will store our timestamp each time the motion is detected. We can call it detected motion.csv. Okay, and it will be saved in the folder whichever you specify. So output CSV path is specified by path with this file name. The file, if you specify just the file name, the file will be created and stored in your default working directory. And you remember our default working directory is Python project, so it will be stored in the same folder. We have two so we create a dictionary data structure motion, in which we have a key start time which have a value none, and key end time which will again have a value none, and these two values will be written whenever we have a motion. These values will be written in the CSV file. CSV stands for comma separated values. We define a function write to CSV, in which we write not output CSV path dot is file. Okay, so we check if file is present, then we write, otherwise we don't write. With open, so if file is present, then we open the file in append mode, and A stands for append. So with we open the file, and name of the file handle is file. Okay, so we define the field names as motion keys. Motion keys are this is the motion dictionary, and keys are start time and end time, right? So this is a dictionary for which keys are two keys, start time and end time, which are specified into field names. Then we specify a variable called writer, which will have csv.dictWriter. Okay, so we is create a writer, dictionary writer, so that we could write in the CSV file. And if first write is there, then we write writer dot write header. We specify the write header, what are the header values, and then first values are written in the CSV file. And then write row, one row will be written in the motion. The motion will be written into the our file. Okay, we if define a start motion function, when the this function will have several behavior like start blinking the LED, make the buzzer, and save the start timestamp into the motion dictionary. So this function goes on like LED dot blink. Again, the same function will be called. Buzzer will beep for this second to this second. Okay, and we will have our motion function will be passed on start time, date time dot now, current time will be passed on to motion function, and this message will also be printed onto the console. So as soon as we detect a start motion, these things need to be executed. And the case the motion ends, these things need to be executed. What we do, we turn off the LED and buzzer, we save the end timestamp into our CSV file, and we write it to CSV. Okay, then we reset the motion dictionary as well. So end motion is defined as if motion, we start specify the start time as LED, we do the LED off, we do the buzzer off, we note the end time as date time now, and we write it to the CSV folder. Okay, then again what we do, we specify the start time as none and end time as none, because we are resetting everything. Fine. and at the same time we print this onto the console that motion has ended. This is next function which will wait for no motion so that you can ready your sensor as we saw in the previous one. When no motion and when no motion, these are the two properties which we set. When motion is instantiated with start motion function, and when no motion is instantiated with end motion function. And having done all these, your complete program looks like this. So with this program, you can have your whole setup ready and working. Finally, you can save your program in a motion detector py file. So when you run this motion detector py file using the Python 3 interpreter, first you will see reading sensor, indicating that sensor is waiting for everything to cool down, stop, so that it could ready the sensor. And when sensor is ready, then you wave your hand in front of motion sensor. What should happen? It should detect the motion. It should start the buzzer. The buzzer should start beeping, and LED should start flashing, right? When you stop moving for a few seconds, then alarm would stop. In the console, you should see the following. First, reading sensor and sensor ready, indicating that sensor has instantiated. Motion detected when you wave your hand. After stopping the wave handing, after some seconds, it will display motion ended. Then again motion detected, motion ended. This will continue for some time. Okay. And in CSV file, you can see that it is the header, the start time and end time, and then timestamps. Like these timestamps are mentioned separated by comma value. And these are the values which will be mentioned in your CSV file. And if you want, you can utilize those timestamps to detect whenever a motion was detected. So this way we can have a burglar alarm also. So this was a very small and crisp uh, introduction of Python uh, along with the Raspberry Pi module, with which you could utilize the Python programming to interact with an IoT device. That's the Raspberry Pi. So Raspberry Pi is a complete computer, and you can have your own programming on RPi to achieve whatever functionalities you want. So this way, I end my lecture over here, and I hope this was useful to you. I'll pass on this file to Dr. Tripathi so that he can share it with you all, and you might also benefit with the lecture that I have prepared. I'm ready for the question if there is any.
Sir, good afternoon, sir. This is
Yes,
Rajeshwar from RCRT Chandrapur.
good afternoon, sir.
Sir, actually, at the start you said that if we can directly connect keyboard mouse, it is very easy to install anything. But with SSH, as we deal with command line interface, how to upgrade the software, what will be the command, and from where we can install it.
You want to install what? SSH, or you want to install
SSH.
PIP?
SSH, yeah, while when we use SSH, we actually dealing with command line interface, isn't it, sir?
Yeah, yeah. You can
From
use
that,
PuTTY. You can use PuTTY on your actually
okay, sir,
SSH.
we are connected to Raspberry Pi, okay?
Fine. Mm.
But I want to upgrade anything. Say Python 2 is installed in my Raspberry Pi, and I want to upgrade it to Python 3.
Mm-hmm.
Using SSH, is it possible to upgrade?
Yeah, definitely,
Or
definitely possible. In fact, it is more easier than on SSH, because see Python pip install upgrade will upgrade everything for you. Okay, so you have to run the
oh,
pip command, and using the pip command, it can pip install update. It will update everything for you, whether it be Python or whatever libraries you have installed for Raspberry Pi. Okay,
well, come on, can you repeat
this
the command there?
pip install. Okay, I will
Pip
share.
install. Okay.
You just message me, sir. I will share the exact command, and I will solve the problem. It's just a number of sequence of commands which you need to run.
Okay,
First
sir.
one is
Definitely,
upgrade.
sir.
So
Definitely.
upgrade will actually it's actually called the pip package. We call the pip package. So PIP. and it will install all the updates, and it will upgrade all the packages which are there to the latest version. So that you can do it through SSH. In fact,
Okay.
it's easier through SSH than through AOD.
Link the Raspberry may damage something, but using SSH we are in user mode,
Yep.
not in a root mode. Actually, Linux is not compatible with all of lots of people because we are prone to work on Windows, isn't
Mm-hmm.
it? Linux is very
Yeah.
new to all the
No, no.
people.
Over here, you see, when you install the Raspbian, okay, while installing Raspbian, you will become a root user because you have given your username and password. So if you use the same user and password while SSHing, you will become root user. So immediately you will get all the privileges. Okay. I hope I
When
was
needed.
clear enough.
Oh, thank you so much.
So,
Okay.
any other question from any other participants here? So any question from participant? No. Okay. So with this note, as I'm not getting a response here, I don't see any questions from participants in the chat box also here. So with this, I assume okay, there's no further questions here. So now we'll close the session here. So I would like to thanks a lot Dr. Muneedra Jha for sharing such a good technical sessions here in such a beautiful manner here. This was very informative for all of us here.
Thank you, sir.
So now on the behalf of organizing team here, I request my co-coordinator, Dr. Manoj Kumar Majumdar, sir, to give a memento here as a token of love from our sides here. So now I request, sir, please hand over the memento to the sir here. Now I request, please take Dr. Manoj Majumdar. Actually, it's not coming. Okay. No, no, it's perfectly visible here, sir. Okay. Thank you. Okay. So with this, I will thank you again to the Dr. Ojha here for taking the valuable time from his busy schedule and sparing a few minutes with us and sharing his knowledge with all the participants here. Thank you very much, sir. Okay. So now I'd like to request the participants again here related to the everyday attendance link here. So you need to be very attentive in fulfilling the links because based on that you will get the attendance here. So you need to be very responsive to the link here whenever it is shared here. Correct. So if you have any other question, then you can ask me. Otherwise, we'll close the session here and we'll meet tomorrow here at 10:30 a.m. morning here with first session. It will be on the IoT and the smart cities, and the speaker is Professor O.P. Vyas from IIIT Allahabad. So he has a very good academic experience here. So more than I think more than 20 years academic experience here. So he has a lot of research collaboration with the foreign universities. So a lot of informative as well as new things we will know here in his session here. So with this note, I will close this session obviously, yes, and thanks all the participants here for being having so much patience and listening to us. Thank you very much.
Thank you, sir. Chalo.